Remember, all we're doing is a limit here. So when we look at the graph of this, I'll show you what this will look like. When we look at the graph of this, what's the limit at x equals 1? Well, from the right side, it's approaching 5. And from the left side, it's approaching 5. The limit exists, it's 5. Now, the function does not exist at x equals 1. You plug in 1, you get 0 on the bottom. That's undefined. But doesn't mean it doesn't approach that same from both sides, so the limit does exist. Well, without graphing, we already know what the answer is going to be. We're using L'Hopital's rule, so it says use that rule. They're just letting you see that from the graph that that's what's happening. So it's derivative of the top, derivative of the bottom. If we have that fraction, what I'm going to do is just one of those rules of a limit where you can pull out that factor just out to the front, just that number, like same if we were doing an integral, right? An integral is just a limit. It has the same type of things, and if we had a 5x, we'd take out the 5, just make it easier to do. Same thing I'm doing here. Just take out that 5, maybe, leave it for the end if you need to. You plug in 1, though. Ln of 1 is 0. 1 minus 1 is 0. 0 over 0 is undefined. Got to do something. We're going to take the derivative of the top and the derivative of the bottom. And so we get 1 over x for x, just 1 over x. You plug in 1, you get 1 over 1. But don't forget, I factored out a 5, so I'd really have 5 in there that whole time if we hadn't done that. So it ends up being 5, which you can see from the graph. All right, 1 through 9. We're not gonna actually do 10. It can't be done. They threw it on there and said, see if you can do it. Actually, they threw a couple on there and said, see if you can do it. And one of them you actually can't do. So we'll get to 9 and that'll be it. All right, so derivative of the top, or you could factor out the 3 if you want to. It would be 3. Derivative of the bottom is 1 over x plus 1. There's an inside there, so you need the extra derivative of the inside. The derivative of x plus 1, though, is just 1. Times by 1, it's not going to affect anything, so we're good to go. Dividing by a fraction, which is the same as multiplying by the reciprocal, which, okay, well then, don't really need that. Just 3 times x plus 1. What happens if we plug in 0 now? 0 plus 1 is 1 times 3 equals 3. Sometimes limits are easy. Just plug it in and you're good. And you can see that's what our limit is 3. If I did that too quick, feel free to go back and try those derivatives again and take your time going through there, or find that someone who can answer your question and see if you can't get a better explanation for that. Okay, looking at our set of examples, L'Hopital's, you have that fraction, you can do the derivative of the top, derivative of the bottom, and you're good. How many of those look like you have that ready to go? Like you have a top and a bottom, you can just do the derivative. None of these. Probably going to happen like that on your quiz, where you're going to have to do some things to get it to look or be in a position to even use L'Hopital's rule. So let's try a couple of those things. The first one, how am I going to change this? Equals the limit of ln of x. If you have a power, just move it to the bottom. Now careful, that 5 cannot be moved to the bottom. The power is not on the 5. It's just on the x squared. So that can move, but that 5 has to stay put. Again, actually, if you want, we can factor out that 5 all together and not have to worry about it. Just don't forget to multiply by it at the end. Now we could do the derivative of the top, derivative of the bottom. This next one, 4x, move the e down to the bottom. Maybe even factor out that 4 again if you want to. The next one, can't really just move something. We actually have 2 different terms. You're going to have to combine these terms. Again, I haven't plugged these in, but I'm assuming we plug these in, we get something that's in an indeterminate form, like 0 over 0, or infinity over infinity. Or this one, you plug in pi over 2 to tangent, you get 0. Let's see, pi over 2 would be 1. But anywho, not going to work out. So let's just kind of keep going here with this idea that we need these to be a fraction in order to use L'Hopital's. So to get this to be the same, I'm going to rewrite this. Secant is 1 over sine, oops, sorry, 1 over cosine of x. Tangent is sine over cosine of x. And actually, we already have a common denominator here. So I would get 3 minus 3 sine of x over cosine of x. And now we have it as a fraction. Now we can do L'Hopital's rule. Try the next one. I don't have a common denominator, but I can get one. I'd have to multiply by x plus 1 there. So that gets multiplied by x plus 1. And this factor would need to get multiplied by x minus 1. X minus 1 on the top. And our common denominator would be x minus 1 and x plus 1. You multiply those together. That's the difference of two squares. If you don't believe me, multiply it all out. Foil it if you got to go back and you don't remember that you're just going to get x squared. The two middle terms are going to cancel, and a negative 1. On the top, we're going to get, let's see, the x squared, distribute that so I can find my derivative easier. I'm going to get x cubed plus x squared. And this one I'm going to get x cubed minus x squared. But be careful. Look at my sign in there. We're subtracting that whole thing. And again, almost ready to do it, but I might as well simplify this before going to the next one. So before I take the derivative, top and bottom, I'm going to take x cubed minus x cubed. That's going to be nothing. X squared minus a negative x squared is actually plus x squared, and we're going to get 2x squared. So now we're in a position where if it doesn't work out, if you plug in that infinity, you get infinity over infinity like we are, and it's like that's an indeterminate form. We can use L'Hopital's. Okay, a power. How do you get a power as a fraction, or anything else for that matter? Well, the tangent can be written as a fraction, but you're still going to have a power. You have an exponent in the top and the bottom. So what we usually do is you take the natural log of that, if we were solving an equation, for example, and that lets me bring that down to the front. Okay, but I can't just take the natural log of something for fun if it's not doing it to both sides of an equation. So here's what we're doing instead. We're taking and just multiplying by a value of 1, which you're allowed to do. Multiplying by a value of 1 doesn't change it. Times 1. E to the ln, those cancel each other out. It's like an inverse of each other. It's just like no big deal. However, now you bring it down to the front and you have e to the, well, that sign would come down to the front, the power of that. So it would be times sine of x times ln of tangent of x. It's not as good handwriting in this Smart Notebook as I have in Word. But hopefully it's good enough you can kind of follow along and read it. But that's what we're getting. Still not a fraction though. So then I guess what we're going to do is we're going to take out the e to the front. That's just a constant, e to that power. So e to the limit now. So don't forget to do that when we're done. And sine I can't really rewrite as a fraction. Oh my goodness. What can I do with that then? Is there any way to get that as a fraction? Any ideas? You could split up the tangent, but that's still in the ln's together, and a tangent of 2 being divided only splits it up into subtraction, doesn't really get division. How do you move the sign down to the bottom? It'd be 1 over sign. It'd be like the inverse, it's not the inverse sign, but kind of like the reciprocal sign, which would be cosecant. I might not have thought to do that, but that's what we got to do to get that as a fraction. Also, don't forget your e. And might see something like that. It's a little crazy, but that's kind of what we're trying to figure out and part of what we're learning here. Okay, same type of thing here. You could factor the 3 out to the front if you wanted to. I'm going to leave it there. But to get this, I'm going to take the natural, get this so it doesn't look like it does, and get that x out of the exponent. I'm going to take the natural log of that And then my rule is I can bring that down to the front. But again, you can't just do the natural log. You have to do e to the natural log of that. Otherwise you'd be actually just changing your function. You can't just change your function. And that constant e can just be taken out again from our limit. So when we're done, we'll take e to the value of our limit. And I can scribble that out then. And again, that's not a fraction, but maybe we can change it to 1. Move the x down to the bottom by making it a negative power. So I move the x one time and got that to be out in front, and then I moved it a second time to get it to be on the bottom. Every single one of those had to do something a little different to get it written as a fraction. The last one, number 9, the last one we'll end up doing Arrhenius, so maybe that'll actually end up being easier. Let's do some of these derivatives now. L'Hopital's. Once you get it in a fraction and you can do L'Hopital's, just derivative of top, derivative of the bottom. 1 over x, or maybe you want to write that as x to negative 1 if it's easier to simplify with what we get. The power on the bottom, do the power rule. Subtract the power, you'd get negative 3. Or if you want to rewrite that, I mean, we can do this a lot of different ways. If you wanted to change in both the powers, or if you want to change in both the fraction, this is negative 2 over x cubed. And that would actually flip up, so it'd be x cubed over negative 2, which would cancel that x and just make that an x squared and give us x squared over 2. Now when I plug in 0, I get 0 squared, which is 0, over 2, which is 0. And actually, did I take out the 5 at the beginning? I did. So I'd have to multiply that by 5. But if you do that, you're still going to get 0 if you multiply by 5. Not the only way to get the algebra to work out, but that's how I got it to work out that time. Derivative of the top is 4, or I could have taken that from the beginning. Derivative of the bottom is e to the x. Now when I plug in infinity, I get 4 over e to infinity is infinity, which is basically 0. It's like so little compared to infinity. 4 is, the limit ends up being 0. So I guess just guess 0. Well, that's not true. I'm not going to give you, if you just write down 0, I'm not going to give you points for it. You got to show me some work here. Not doing all that in your head. All right. 3 minus derivative of the top. Derivative of 3 is, well, just nothing. Negative 3 cosine gives you, wait, can I plug this in? Pi over 2. Nope, I'm still getting undefined. I'm still getting 0 on the bottom. So derivative of the top would give me negative 3 times cosine of x, and the bottom would give me negative sine of x. Now I'm getting 0 on the top, right? Pi over 2 for cosine is 0. Pi over 2 for sine is 1. So negative, it doesn't matter. 0 over the negative 1 or positive 1 or whatever it's going to be is going to be 0. So 0 again. And I think that won't happen this time. Derivative and derivative, once you have it in this form and the limit doesn't work out, you get like infinity over infinity. You get 4x, 1 less power, and 2x, which the x is actually just simplify, so we get 2 no matter what we plug in. Interesting. Okay, there you go. And it's going to be 2. Let's see, I was about to do 8. Number 7. Kind of looks like a tough one here to do some derivatives for, but let's just see what happens, and we'll plug in 0 and see what we get. The ln of tangent, so it would be 1 over tangent times the extra derivative of the inside. Remember the derivative of tangent? That'd be times secant squared of x. Derivative of the bottom, what's the derivative of cosecant? It's negative cosecant. I should have given you a chance to try to remember that. Cotangent of x. And I hope we don't have to do a derivative a second time, because remember, sometimes you do the derivative the first time, top and bottom, it doesn't work. You do the derivatives a second time. We haven't really had to do that much yet. But shoot, if we had to do it a second time, we'd have power rules and all sorts of fun stuff we'd be looking at. Or maybe we'd try to simplify first, I guess. But anywho, let's see kind of what goes on here. We're going to plug in 0. Let's get our 0 going here and see what we get. See, tangent would be sine over cosine, which you know, that's still going to give me a 0 for, well, maybe what we could do instead, I was going to say we're going to get a 0 over 1 there, and that's going to be over 0, 1 over 0, and that's undefined. But let's do, instead of 1 over tangent, let's do cotangent. Because then when I plug in 0 for cosine and get 1 for sine, that'll just be 0 times, let's see, 1 over cosine squared is, well, that's, is that still 0 squared? Maybe I can simplify this a little bit more because I'm still getting 1 over 0. Alright, so let's say we said all that, and if you forgot what was there, where it came from, you can go back. But we're going to say that's cotangent, which is cosine over sine. And this is secant squared, which is a couple cosines on the bottom there. So we would get one cosine to cancel. And let's see, what else can we get to simplify here? On the bottom, we have, I feel like I'm going to lose my place. Okay, on the bottom, we have cosine. Actually, hold up. I guess I could keep going, but I just had cotangent and secant squared, right? So we took, we had 1 over tangent, which is so you'd flip that, you get cotangent times the extra derivative, so that's right. I have a cotangent on the bottom too. I could cancel those out and not have to worry about them at all. Alright, so then what do I end up with? I have 1 over cosine squared, and I have 1 over negative 1 over sine. So that sine would go up to the top, right? Sine over 1, and I get sine over cosine squared. And at 0, sine is 0, and at cosine, we get 1. Okay, well that's just 0. Oh. 0, 0 again. Crazy. Well, except, what happened to my 5 and my e? I almost forgot that. We have 5, if I factored out the 5 before doing all that, because I forgot that in there, and I still have to take e to that. What's e to the 0 times 5? E to the 0 would be 1, times 5 would be 5, and you know what, if I wasn't 17 minutes into this video, I might do that one again, because I feel like I didn't, because I forgot to say that as I was going through. That might be confusing, but we've got one more that'll be similar, so hopefully explain it well enough to follow, and if you need to go back and try it again and try it on your own then, or watch it again, feel free. It's up to you. Okay, so I didn't factor that 3 out first, but if I had factored that, maybe I'll do that this time just so you can see what would have happened. What I did on that first one is I forgot the 5, which was okay because you could have pulled that out before doing all this other stuff. Then do the e and the ln, so I'll have 3 times e to the limit. So we'll take rid of that, care of that 3, and we'll do this one the same way. And if you forgot, wait, how do we get here again? Just scroll back your video and find number 8 where we change that to a fraction. But from here, we just end up with, I'll rewrite this, 3 times e. Well, then I could do it like this. Three times e to the limit as x approaches 0 from the right of, and then we've got this change to be ln of x over x to the negative first. And so to do that limit, if I plug in 1, I get a 0. It's undefined. It's like we're getting something funky. We can't really look at that, so we're going to do the derivative of the top, which is 1 over x. Derivative of the bottom, which is a power, so we multiply by negative 1 and subtract the power. If it helps, if you can't see what this is going to be without rewriting it, feel free to rewrite it. So that's 1 over x squared, which would multiply by the reciprocal or flip up to the top when you're dividing by a fraction. And you've got that negative there. That would cancel an x. and we just get negative x, which, what do we plug it in? 0? Well, negative 0 is 0, but we have 3, so our limit is, this whole thing is 0, but we have e to the 0 times 3, so e to the 0 is 1 times 3 is 3. Promise this last one will go quick. I shouldn't make promises, but I think it's going to go quick. It's already in a fraction, and I don't think those derivatives are going to be hard to find. Do the derivative of the bottom, because you just get 1. It's like, well, you don't even need that. Anything divided by 1 is just the same thing. Derivative e to the x is e to the x minus e to the negative x. So the derivative of that would be e to the negative x times the extra derivative of the inside. So times a negative would be a minus a negative. Two negatives change to a positive. So we have e to the x plus e to the negative x. We're plugging in 0. What's e to the 0 plus e to the negative 0? E to the 0 is 1. You could put over 1 if you want. Plus another e to the 0, which is another 1. Ends up being 2. Sorry, you can try to do the last one if you want, but you can't be done. So that's it. Good luck studying for your quiz.